Alright, so I'm recording already. Recording. Oops. Alright, I'm recording already. So just want to check. Okay. Alright. Okay, so how to solve this question, yeah? So here you have a bus, okay? Bus traveling steadily at 30 meters per second along a straight road passes a stationary car, which 5 seconds later begins to move with uniform acceleration of 2 meters per second square, okay, in the same direction as the bus. So determine the time taken for the car to acquire the same velocity as the bus. And then the distance traveled by the car when it is in level with the bus. So these are two different questions. The first question is, as you can see here, got two objects. One is the car, another one is the bus. Okay, so the first question is acquire the same velocity. Car and the bus acquire the same velocity. And then for the second question is the car level with the bus. Okay, so all right, so what's the difference? Okay, let us first look at let us draw a picture to describe this question. This is quite a challenging question. Okay, so how to help ourselves? Please draw a picture. Okay, it always helps. Yeah, draw a picture. Okay, so here you can see there is a bus and the car. Let us draw. Yeah, someone just enter. Let me just accept first. Okay, welcome, Haswani. Now, okay, another one. Okay, welcome. Okay, good evening, everyone. So, example 12. Yeah, this is the questions found in the lecture note. Okay, so this bus. Okay, let us draw the picture. Someone just entered. Okay. All right. So okay, so here's the bus. Yeah, here's the bus traveling. With initial speed of 30 meters per second. Okay, passes a stationary car. So this is a car. Okay, the initial velocity is 0. Yeah, because car is not moving. Okay, he says this is important. He says 5 seconds later, only the car start to chase. So excuse me. So the car does not immediately chase. It's not the same like the tutorial questions you did. The tutorial question you did is the police car immediately chase the the motorist. This one is the car. He only chased 5 seconds later. That means after 5 seconds, the bus already traveled a certain distance. After 5 seconds, excuse me. Okay. Firstly, 0 second, the bus passes the car. Okay, the bus passes the car. But the car does not immediately chase. It chased 5 seconds later. That means the bus already traveled certain distance. Maybe this is a reaction time lah. I can say this is some reaction time of the car. Okay. So after 5 seconds, okay, after 5 seconds, excuse me, the bus already traveled certain distance. It already traveled certain distance. So okay, certain distance I put as S1. I put as what should I put? S1 lah. Okay. Okay. So someone just entered, yeah. Excuse me for my throat, yeah. So 5 seconds later, only the car start to chase. So, all right. He travel, okay. 5 seconds later, the stationary car start to give acceleration of 2 meters per second square. So this is the acceleration of the car, yeah? Acceleration of the car. So the car start to accelerate at 2 meters per second square in the same direction as the bus. So okay, let's talk about point B first. Yeah, point B. Yeah, for the question B. Let's do question B first. Yeah, distance traveled by the car when in level with the bus. Okay, what is it mean by question B? Distance traveled by the car when level with the bus. That means after some time, the bus and the car at the same level. After some time. That means the car successfully chased the bus. In level lah. This is what I mean by in level. Level with the bus. So he want to find the the total distance from here until here. The distance traveled by the car when level with the bus. That means the car chased the bus lah. Successfully chased the bus. So you want to find the displacement, distance traveled by the car after catch the bus. Okay, so how to find this? So question B is want to find this displacement of the car. Class, do you understand? Can you keep up with what I teach here? You understand? Yeah. Hopefully, you can give some response to me. Okay. Okay. So thank you for your response. So so okay, let's do B first. So what I can say is displacement of the car, it is equal to, so that means the car have to travel a longer distance in order to chase the bus. So I can say that because the car does not immediately move to chase the bus, the car only move 5 seconds later. So that means the bus already travel certain distance to the front, somewhere over here after, let's say, displacement 1. So that means car have to travel longer distance. So what I can say, put this one as displacement B. Displacement B. So in order for the car to chase the bus, that means this SC must equal to S1 plus SB. That means the car have to travel very fast to cover the the distance move during the 5 second. Because the car hasn't moved, so you have to cover the distance of the 5 second travel by the bus, and then some more you need to cover the displacement of the bus until he meet up again. So okay, first of all, let us find S1 first. So this is the answer lah. This is the most important formula you must know for question B. To find the answer for B, you must use S1 plus SB, get the displacement of the car. So let us find S1 first. So S1 itu ialah, that means during the 5 second, berapa lah bus sudah bergerak, berapa jarak sudah bus bergerak, tapi kereta belum bergerak. So how? So this one, the bus travels steadily The bus travels steadily. That means acceleration of the bus is 0. Okay. So bus has no acceleration. Bus itu tidak ada acceleration. Dia just a constant velocity. So you just put okay, s equal to ut plus half at square. Tapi the bus no acceleration, so just s equal to ut je. So velocity of the bus is 30 meter per second, and for 5 seconds, so this is 150 meter. 150 meter. So this is that means ini sudah bergerak 150 meter ke depan. Tapi kereta belum bergerak lagi. So sekarang so itulah dia. So nak cari kita sudah dapat S1. So ini ialah 150 plus SB. Understand? So now we can put formula. This is displacement of the car. So S equal to ut plus half at square. S equal to ut plus half at square equal to 150 plus so this is by the car. This is of the car. This is all car displacement of the car. Okay, and then displacement of the bus. Okay, displacement of the bus also just because bus is constant velocity, because travel steadily, yeah. Acceleration 0. Acceleration 0 means velocity is constant. So bus dia tiada acceleration. So dia just ut je lah. Dia just ut saja. Ut. This is a bus. This is a bus. Ini bus punya. Ut je. Okay. Now, so car initial velocity is stationary. Kan kereta awal-awal dia u dia kosong. So kita boleh letak ini u kosong. Faham tak? Sebab dia tak bergerak mula-mula. Okay, half. Acceleration dia berapa? Acceleration dia 2. Acceleration 2. And then find the time. Find the time when they meet up. Plus u. Initial, the velocity of the bus is 30. 30 t. Okay? Ini bus punya. Ini kereta punya. So very simple, you see. So let us okay. So I think you can this one use quadratic lah. Yeah, quadratic. So t, you got t square minus 30t minus 150 equal to 0. So can you find the t? Can you find the t? This one 3 times. So can you find the t? Use your calculator. Let us use the calculator. So equation. Okay, so what time do you get, class? Can you help to use your calculator? Find me the time here. Yeah, someone? Okay. What's the time? What's the time you get, class? Ada sesiapa? Boleh kira untuk saya?
The first one.
Sorry, I can.
34.36.
Ya? Berapa?
The first one 34.36.
34.36. 32.36. Okay, thank you. 32.36. Ya, betul kan? Another time is what? Negative, is it?
Negative 4.36.
4.26.
36.
So this one ignore lah, yeah. This one ignore, yeah. The time, negative time ignored. So just take the positive time. Okay, so this is the time when they meet up. So this is the time when they meet up. So this is the time 32.36. They meet up. Okay. So so how? So we want to find the distance, kan? We want to find the distance. So you just take of the car, distance of the car. That means I want to find SC. So just use the time and find the SC. SC is...
Sir, it's 34, not 32.
Oh, 34. Okay, thank you. 34. Okay, so find the SC again using the same time. Okay, yeah, the car is stationary initially. So half acceleration is what? Acceleration is 2, and then 34.36. Where? So what answer do you get? 34.36 square. So the answer is, what answer do you get, class? 34.36 square. So yeah, I got 1180. Okay, 1180 point berapa ni ya? 0.61 meter. Okay, is that correct, class? Yeah, see, 1180.80. Yeah, almost there lah. Okay. So itulah cara dia, kelas. Faham tak? Faham tak? Okay, bagus. Okay. So now let us look at question A pula, ya. Question A bukan about distance, is about same velocity. Maksudnya kalau in level dia punya velocity lain, dia bukan same velocity, ya. Sorry, very noisy outside, ya. Bila ada anak di rumah memang sangat bising lah, ya. Okay, so the car here is traveling very fast lah compared to the bus. So if you want the same velocity, maybe the car is over here. Maybe the car is still somewhere behind here because the other acceleration so the car is somewhere behind the bus when they have the same velocity. So we want to find the same velocity. Same velocity, that means VB ataupun tulis VC dulu. VC equal to VB. VC equal to VB. So what's the time taken at the same velocity? So okay, let's find out, class. So just use the formula of what? Yeah, I think you just use the formula of what. Just use the formula of what? Yeah. V equal to U plus AT. So this of the car. Actually, the bus is constant velocity. 30 meter per second. So just put 30. Okay. So initial velocity of the car is of course 0, and then he give chase at the acceleration is 2. Find the time. Actually, this is simple, yeah. So the time taken is 15 seconds. Yeah, 15 seconds. So that's the time when they have the same velocity. Actually, this time does not include the 5 seconds. Yeah, this time does not include the 5 seconds. Yeah, this time is measured start from after the 5 seconds. So this time is not including the 5 seconds. Yeah, this 15 seconds is already excluded the earlier 5 seconds. Yeah. So atau maksudnya the total time, actually the total time is 5 seconds plus 15 seconds. If you want to measure from the time when they meet up the first time, when the bus passes by the car the first time, then the total time is 20 seconds. If you want to include the 5 second, the earlier 5 seconds, then the total time is actually 20 seconds. If you don't want to include the earlier 5 seconds, then the time taken is only 15 seconds. So if you ask me whether want to plus the 5 second or not include the 5 second, what I say is for this question is not clear. It's not clear. So it's not clear. So the answer scheme can have two answers. Can have maybe 20 seconds or 15 seconds. Yeah, some lecturer will argue 20 seconds. Some lecturer may say 15 seconds. So I think they will accept both answer lah. Okay. Judging from the question is not so clear. Yeah, the time started from earlier or later. Yeah. So itu sajalah untuk soalan ni. Boleh faham ke kelas? Boleh soalan ni? Boleh ya? Okay, baik. So can have two answer lah this one. Yeah. So baik. So looking at the next question, yeah, some student also cannot do this. So let us just discuss here. Okay. So correct. Okay. Yeah. As soon as the traffic light change to green, Abdullah accelerates uniformly with his motorcycle at 2.6 meters per second square for 5 seconds. He then maintained steady velocity for 2/3 of his 150-meter journey. How far does he travel from traffic light junction until he reaches a maximum velocity? Okay, so imagine this question. Traffic light become green. So Abdullah press the start to accelerate the motorcycle. Press the oil. And then so got acceleration. Just right there, I want to write first. This is the acceleration. So the time this is the time taken. Yeah, and then maintain steady velocity. So steady velocity means v is constant for some point. For how long? For 2/3. For 2/3 of his 150 the journey. So this is the total displacement. The total total displacement. So maintains okay 5 seconds, 2/3 of the. Okay, so this question 5 seconds. So what's the total time? So okay, you see the question. How far does it travel from traffic light junction until he reach a maximum velocity? What maximum velocity? How long does it take to come to rest when he slow down? Oh, that means he did slow down. It's not just travel steady velocity for 2/3. So this journey, 150-meter journey, he did slow down after some point. You must read the whole question to really understand. You cannot just read the first part and then that's it. You must read the whole question. Then you can only understand the situation. So this one is how long does it take to come to rest? He did come to rest in the end. If he then slow down finally the velocity is 0. Okay. Slow down at as this is deceleration already. This is deceleration. Read. Negative 1.4. Okay. Mula-mula dia punya acceleration is positive 2.6. And then constant velocity, and then finally slow down. Okay, so can you imagine? Maybe you can draw a graph. Why not, class? You can draw a graph. It helps. So I think you draw velocity time graph. Okay. Okay, let's draw a velocity time graph. It helps. Oops. Maybe the shapes, Okay, like that. That'd be nice. Okay, so velocity time graph. So this for put it down here. So velocity, okay, time graph. Okay, so so that means it travel, like that, then like that, or constant velocity and then slow down. That's it. That's it lah. So that means what information? Okay, so what I know is 5 seconds, right? He did say for 5 seconds kan, until he become reach a maximum velocity kan. So this is the maximum velocity Vmax. Do you know the Vmax, class? No, you need to find. And number 2, we need to find the Vmax. So okay, I know the 5 second. That one he say accelerate 2.6. What it means here is the gradient of this graph. The gradient of this graph is 2.6. 2.6 for this gradient of graph. And then maintain constant velocity for 2/3 of the journey. 2/3. That means how long? If 2/3, it gives a hint about the time. Understand? How long? 2/3. How long is 2/3? And then, of course, we don't know what's the total time of the journey, right? We don't know the total time. But he did give the journey is 150 meter. This is the total displacement. So total displacement is area under the graph. So this question got a lot of concept. This is some question that you need to do. You need to do more exercise. Then you can know what to ask. You only discover your problem after you do more exercise. So, okay, every subtopic have questions. You must do it. Yeah. So okay, area under velocity time graph. The total area here. What I mean here, the total area. The total area here is 100. Is 150 meter. 150 meter. So okay. So how? So let me see. Okay. Okay, so how? So okay, 150. So how does it help you? How does it help you? You don't have the maximum velocity, but you have the gradient. How will it help you, class? How will it help you? This acceleration can help you to find the maximum velocity, right? Yeah, kan? Okay. How far does it travel until he reach a maximum velocity? For question number 1 is traffic light change to green. Okay. So how far does it travel until it reach a maximum velocity? That means the first part is the very noisy. House is very noisy. Crying here, crying there. So the first one question, this is area under the graph, right? And how far? Ask for displacement. So there is the area. This first part. What's maximum velocity? Okay, so I think you can do it already. So how to find how far? How far? That means want to find the area and the graph. I think better you find maximum velocity first. Done? Find the maximum velocity first. Do question 2 first. Yeah. Do question 2 first. I think you can do question 2. Okay. So maximum velocity that is the gradient of the graph, dv dt, isn't it, class? So you see, you draw a graph, then the thing become obvious for you, isn't it, class? So okay, so that is the velocity, Vmax. Just take, this point, just take this point minus this point. So which is Vmax minus 0 over 5 minus 0. I want to find gradient. So which is 2.6. Isn't it, class? So Vmax is equal to, let's calculate. Yeah, let's calculate, class. 2.6 multiply 5. So we get 13 meter per second. Okay, so I got the Vmax. So I got the Vmax already. So after I got the Vmax, easier for me to find the area for question 1. So question 1, I want to find how far it traveled until it reach a maximum velocity. So firstly, you may thought this is a question for the kinematic formula, kan? But it appeared to become is a graph question. It become a graph question. Yeah, it can be, Actually, if you look at here, this is actually a kinematic formula. This is actually formula from, A equal to V minus U over T. This formula actually comes from V equal to U plus AT. So this is still a kinematic formula, class. This is actually a kinematic question also. Kinematic formula question. Just that you don't see it. Yeah, it's not so obvious for you. Ini tukar ini. Actually, ini benda ini lah ini juga. Okay, tak apa. Tengok balik pada ini. Soalan 1. So how far this one is, area under the graph. Area under the VT graph. So which is half the triangle. Half 5 times. What's the Vmax just now? I got 13. So 13. Let's calculate 13. So let's calculate. So 5 times 13 divided by 2. So I got 32.5 meter. That's it, class. So that is the answer for number 1. 32.5 meter. He traveled from traffic light until he reached a maximum velocity. So this is the distance he moved before he become maximum velocity. Okay, so got the answer. Question 3. How long in total does it take to come to rest? If it then slow down at 1.4. Okay. What is the how long in total? Total. The word total. That means, does it take to come to rest? That means, what is the total time lah? What is the total time of the whole journey to soalan dia? How long is the total time? You rasanya macam mana, kelas? Ini sangat senang, kelas. Kalau I got the whole journey 150. 150. So that means what you need to do, this is a trapezium. This is the trapezium area, understand? So formula dia ini actually this is the key, class. This is the key. So question number 3, question number 3. Let's do it. Question number 3. How good if I have a tablet like all of you write so smoothly. This one I still use Wacom. I don't have a tablet like you all. Okay, so displacement is the total displacement, which is area under the graph, is 150 meter. Okay, and it is actually half the trapezium area, ya, ataupun the trapezium area, ya. I didn't how to spell the trapezium? Trapezium area of the velocity time. Okay, so that means trapezium, how to one half the height. The height I already know. The Vmax. Vmax is 13. And then apa tambah apa? Saya perlukan ini. I'm missing one information. I don't know what's the time here, isn't it? I don't know what's the time here. I need this time to, because okay, I know this length T tambah dengan ini. Ini saya tidak tahu. So it is the T, the total time. First, the total time is berapa? Total time. That is the answer. I need the. I also don't know that one. I don't know this one, and I also don't know that one. The total time here. Total time here, I don't know. Plus with another. So this is crucial. I need this. So how? Plus. Okay. So, okay, another clue here, he says slow down at 1.4. So here, this one is acceleration equal to negative 1.4. It will help. The gradient can help us to find. Okay, let us write the maximum velocity here. Yeah, 13. This is 13. Okay, so 13. I can find, if I know the total time here, definitely I can find the time here, isn't it, class? So because I got the gradient, I can find the time here. So how class? Yeah, slowly, steadily, we can get the answer, class. 150. So he said 2/3, right? He said 2/3 of the journey. Third of the journey. The total 2/3. 2/3. I think you can, find how far, right? Third of the journey, constant velocity. 2/3 of the. Let me see. 2/3 of the journey. That means this one is the 2/3 of the time. Yeah, 5 seconds. So 2/3. Okay, let us try. 2/3. That means what it means by 2/3 here, class. 2/3. 2/3. That means this part is letak itu sebagai sebagai just a letak itu sebagai A lah, ya, letak itu sebagai A. Okay. So A ini ialah 2/3 of the total time. 2/3 total time. Okay. So 5 sec 2/3 means 5 seconds. Whole journey. Best maximum velocity. I got this. Okay, so area ini. Okay, this area is 32.5. That means yeah. Any clue, class? I also maybe I want to ask, do you have any clue that can help? Do you have any ideas? Yeah, you can actually try and think. Maybe you can have a good reasoning. Take rest down at 4. Oh, okay. How long? Okay, class. Okay, I can actually find the time here. I no need to crack my head. Okay, so I already got the, yeah, slow down at 1.4. Okay, okay, I can find how big is this. Okay, slow down. Okay, part 3, yeah. Need some space here. I need some space here. Allow me to write something here first. Okay, so the acceleration equal to negative. Okay, wait. So starting with initial velocity 13, because start from maximum speed, yeah, from here. So final velocity he stopped, and then acceleration is negative 1.4. Okay, I can find the time, right? V equal to u plus at. V equal to u plus at. So v is 0, u is 13, negative 1.4 t. So what's the time, class? What's the time? Let's find out, class. You understand? You understand this one? Wait, can throw off. Okay, so do you understand this one? This one is final velocity at 0 here. Initial velocity 13, and deceleration is negative 1.4. So the time taken here is this one. I can get the time here. This is the time. You understand? Okay. So let us so negative 13 divided by negative 1.4. So yes, this is let me see, negative 13. So this is 9.286 second. Yeah. So here the time taken here is 9 sorry, so this is 9.286. So here is 5 seconds. Here is 5 seconds. Here is 9.286. So this is 2/3. The constant velocity is 2/3 of the journey. So how long? That means the other time is only 1/3. Understand? Before and after is only 1/3. So the middle one is 2/3. You get what I mean, class? So you definitely can find the time here. So that means okay, so 5 plus the 9.286 is berapa? Okay, that means put it this way. Okay, put it so T1 plus T2 plus T3 equal to the total time, because got 3 section, yeah, 3 section, T1, T2, T3. So T1 is 5 second, and I want to find the T2 last. I need to find the T2 before I can find that time. So this is 9.286. Oh, I need the total time. I don't have the total time. Okay, but this time is 2/3. Yeah, I got it is 2/3 of the total time, isn't it, class? This is the middle one. The middle one is 2/3 of the total time, isn't it? So that means outside is You know why I take a bit long time to think of this question? First, this question is a bit hard, and the outside is so noisy. Yep, yeah, fighting each other. So big pressure. Okay. So this two thing is 1/3 of the total time. You get what I mean? So let us find it out. Let us find it. Yeah. So 5 plus 9 is 6. So this is excuse me. So 2/3 of this is 14.86 equal to so macam mana nak buat ni? Pergi, that means yalah, ini kasih tolak je. So yeah, ini pergi tolak sana. Yeah, so that 14.286 is 1/3 of the time. Is 1/3 of the, kan? Ini 1 tolak 2/3, so is 1/3 lah. So what is the time? What's the total time, class? What's the total time? So the total time, I got it 42.858 seconds. Yes, so that is the total time. The mysterious total time. So this is the total time, 42.585, class. Because this segment and this time and this time add up together is 1/3 of the time. So the total time is this lah. So I can easily find this, class. I can easily find this. So ini tolak yang tadi tu masa yang digunakan. So tolak 9.86. So that time. So I got the time here. This is 33.572. Okay, so you now can easily find how long does it. Hey, wait. Just ask for the total time, isn't it, class? So that's the answer lah. That's the answer lah. 42.85. That's the answer lah. Okay, that's the answer. That's the answer, class. So that's the answer. Actually, I don't need to. That's the answer. How long does it take? So actually, we already got the answer. Yeah. It's just that we no need to find this time also. Yeah. Unless you want to find the area, or area also 150. So what I mean here is this 150. If that means it is, if you really want to find 150, it should be one half trapezium 13 plus the 42.858 plus with 33.572 minus 5, which is berapa? 33.572 minus 5, which is 28.572. That means if you calculate this, you should get 150. Is it true? I'm not sure actually at this point, because I'm not so sure. Is it so difficult that way? 572 times 13 divide by 2. It seems incorrect, class. It seems ini salah, ini salah. Okay, never mind, let's check the answer first. Yeah, so we got it. How far does it take? Maybe this one 2/3 of the journey. Okay, or 2/3 is not the time, maybe it's the distance. So okay, it's incorrect. So I think this 2/3 refer to the journey, not the time. Refer to the journey. Yeah, it refer to the journey. Okay, it refer to the journey. So Okay, never mind. Let's check the answer first. Yeah, I'm sure this is wrong. I'm sure that the question 3 is wrong. Yeah. I guess I understand what it means. The 2/3 is not the, yeah. So which question? This one. Let's check. This is question 3. Question 3. Yeah. Okay, we got the first one correct. Yeah, is it correct? 32.5. Yes, it's correct. 32.5. Okay, and then the second one is 13. Yeah, it's correct. 13. But the time taken is 18 seconds. Yeah, total time is not 42. Yeah, so I'm sorry. Sorry. So it's not 42. I got it wrong because this one 2/3 of the journey is not the 2/3 of the total time. It's actually 2/3 of the journey, total 2/3 of the distance. So I get my understanding wrong. So yeah, I get my understanding. Huh? So I get my wrong. But I think I finally understand the question. Okay, so I'm sorry. So this is not. Oh, this is wrong. These are wrong. Okay, so again. So 2/3 of the journey. So I think 5 seconds. So okay, 2/3 of journey is simple. Just 150 times 2/3. Then I can find the area of this graph. Yeah. So I get my understanding wrong. Yeah. Question 3 again. Try again. Like this. Once you fail, do it again. Okay, so 2/3 of the 150. That is what it means, class. 2/3 150. What do you get? 2 divided by 3 times 150. So it is 100 meter. Just that. So that means area under this graph is 32.5 meter. Area of this rectangle, the constant velocity, is 100 meter. That's it. And how much left? How much area left? How much area left, class? So that means this is 150 minus, because the total journey is 150, right? The total area. So 150 minus 100 minus, that means it's minus 132.5. Understand, class? So it's 150 minus 132.5. Okay, so 17.5 meter. Yeah, so I got the area 17.5. So that will help us with the time, surely. Yeah. I need to find how long, right? So okay. Yeah, you can find the time already, class. So let me just highlight first. Highlight. So okay, that is red. I just put it in different color. Yeah, that I can make it. I can show it clearer. Okay, so that is here time is 5 seconds. So this 100 meter, 13 times what become 100? So that means 13 times the time for the second part become 100 meter. Berapa tu? So T2 equal to 100 minus divided by 13. So it's 7.69. 7.69. So this is 7.69. That means here to here is 7.69. So tambah dengan 5, so ini adalah 12 ya. 12 point apa? 69 kan? 12.69. Okay, so now the small area here. So you can use the triangle here. 1/2 setengah darab dengan apa? Setengah darab dengan panjang T3 darab dengan 13 ialah berapa tu? 17.5. So berapa T3 tu plus? T3 tu. So 17.5 divide by what? Divide by 13 times 2. Okay, so the time taken is 2.692 something, yeah. So 2.69. So that means how? How come? 5 seconds. How long it takes? 2.69, but it doesn't add up. It doesn't add up. Become jawapannya 18. Jawapannya 18. Okay. 18. It doesn't add up. It doesn't add up. How long does it take? Come to rest. Or let's say okay. How long does it take? Wait, what the journey? Okay, wait. I think what's wrong with this question? So S equal to S total is 150. So let's take the trapezium again. 13 times yeah, I need the total time plus with what's wrong with this question? 7.69 lah. I think that equal to 150. So tadi ini 100 meter darab dengan 100 ialah 100 bahagi dengan 13. 100 bahagi dengan 13 memanglah 7.69. Itu memang tak salah. Okay, let us try this. So what do you get, class? So 150 divided by 13 times 2 divided by 13 times 2 okay, and then minus the 7.69, get 15.39 second. Okay, again 150 multiply 2 divided by 13 minus 7.69, I get 13.39. So similarly to just now, if I add up one by one, okay, ini 12.69 tambah dengan 2.69, saya pun dapat nilai yang sama juga, ya. 12.69 tambah dengan 2.69, yeah, I also get 15.38. Yeah, get. So how long it total take? Slow down at I get wrong somewhere. So I got the answer. Yeah, how about you, class? Do you get this the same answer? So this is the answer I get lah. I didn't get 18. I didn't get 18. Okay. I get 18. So this negative 1.4, I think I didn't use the negative 1.4. So I'm curious about this. 1.4. What does it mean? Again, initial velocity is 13. Final velocity is 0 because it's stopped. Deceleration is negative 1.4. So I think you can find the time. Just now I got right. V equal to U plus AT. So 0 equal to 13 minus 1.4 T. So what is a T? Negative 13 divided by negative 1.4. So I got 9.286 seconds. Okay, 9.286. How come 9.286? 0 become initial become slow down, come to rest. So this time become 9.286 is not possible. Class, this question got problems. I'm so sorry lah. This question got problems. Because it doesn't make sense lah. It doesn't make sense to have negative 1.4. This acceleration. This question got problems lah. I found like this question got some problems. Maybe you can. I'm so sorry. I cannot help with this question. Okay, maybe you can try ask other friends or other lecturers and see whether they get what conclusion they get. So right now my answer is this lah, 15.39, and if this 9.286 plus with, because I should get this one 2.69, but when I use the deceleration, I get something else. I get 9.286, which is not the same as 2.69. So I think that's it lah for this question. Okay. Class. So I think time spent for these two questions. Okay, class. So so do you understand what we are discussing? So at least you got for the 12 example 12. For the example 12. And this question, I think the last question got problems. All right. So they at least we cannot get the why I'm trying to show here is, even though we cannot get the final answer, that's not the most important, class. I hope that you see the process. When you do the first time you cannot get the answer, then you try other method. Don't just fix at only one method. Like what I did. Okay, like what I did, they are you work from different route. You can try question like using graph, draw a graph to explain, and sometimes you use kinematic formula to explain. So try until you success lah. Unless the question, I'm not so sure about this question. Unless the question have problems, then you cannot do anything. So always try until you different method. Okay, and I hope that you can see what I'm trying to do just now. My first mistake is I thought the 2/3 is taken from 2/3 of the total time, but no. Here it means 2/3 is 2/3 of the whole journey, 2/3 of the displacement. 2/3 of the total time is different from 2/3 of the journey. It's different. 2/3 of the time and 2/3 of the whole displacement is different. So so I hope that you see something or learn something from today. Okay. Okay, so that's it lah. So thank you for joining. Okay. You can ask other friends also how they work with this question. Okay. Okay, thank you class. Bye. Good night.
Thank you, sir.
Thank you, sir.
Thank you.